Hello everyone, my name is Kushbu and I welcome to you all again in this statistics video lecture series. So in my previous video already we have seen till Z-score formula, how we apply Z-score to a particular distribution, and the resultant distribution that we get is in the form of standard normal distribution, isn't it? So in this particular video we are going to discuss about one another important topic in context of like statistics for data science, is something called as CLI. Now what does it mean by CLI? This is nothing but central limit theorem. Okay, central limit theorem. We will discuss about this particular topic in this video. Let us understand about central limit theorem. So this particular theorem says about when we have a random variable. I hope you understood like what I mean to say random variable. I already created a video on random variable. If you haven't seen, you can go and check out that. So suppose I have a random variable which may or may not belong to a kind of distribution called Gaussian or normal distribution. Means this is a random variable. If I am going to plot this particular random variable, so it may or may not belong to a kind of Gaussian distribution, right? Let's say that this particular x, that is my random variable, let me write random variable, have some mean and also it have some kind of standard deviation. Okay, so this particular random variable have some mean and standard deviation value. Now if I take some samples from this particular random variable, okay, from this particular random variable, if I want to take few samples, right? Suppose let's say I have this sample number 1. Let me denote it as S1. Okay, I have this sample number 1. So in sampling, what we used to do, within a set of population data, we used to take out some samples, right? We used to take out some samples. So in this sample data, we will take out the data point that is like this, that is x1, x2, and till we will be taking till xn. Okay, xn, let's say this n could be any number. This n could be any number, but you have to take care of this, that this n should not be less than or less than 30. It should be always greater than or equal to 30. Means in your sample data set, the number of data point that should be is always equal to 30 or greater than 30. So your sample data should at least contain the data point equal to 30 or greater than 30. Similarly, maybe we can take multiple number of samples. We can take like this multiple number of samples till sm. You can understand. Here also we can take like x1, x2, and till point xn, where this last point should be equal to 30 or greater than 30, not less than 30. Okay, let's say here also I took like this. So if I am going to plot these all samples like with the help of histogram, or let's say any kind of probability density function, so if I'm going to plot these kind of samples that we took from this particular random variable, so the type of distribution that I am going to get is nothing but it will be Gaussian distribution form. Gaussian distribution means, in total, I mean to say that if I am going to plot this particular sample with the help of histogram or probability density function, then the type of distribution that I am going to get is Gaussian distribution. And this particular distribution's mean will be always equal to the population mean. Here, this population mean, I mean to say about this random variable, right? Because within this random variable only we took out all these samples. So I hope you understood about what is central limit theorem. If let me just explain once again. So suppose I have a random variable, or you can understand that I have a population data set, okay, with some mean value, that is mu, and standard deviation value sigma, right? And if I take some samples out of this population, maybe multiple number of samples I took, that is S1, S2, S3, and let it be till xn, right? But there is one condition, that the number of data point that I am going to take it as a sample should always be greater than or equal to 30. Fine. And if I am going to like plot this particular samples after sampling, so the type of distribution that I am going to get is something in the form of Gaussian distribution. And how we will plot this samples? With the help of histogram or PDF, that is probability density function, okay, that is probability density function. Then the type of distribution that I'm going to get is Gaussian distribution form, where mu, that is mean, will be approximately equal to this population data, that is here in this case it's random variable population mean, right? And the standard deviation that I'll be getting will be sigma square by n, where n is always greater than or equal to 30. And also one more thing about this central limit theorem is that the type of data that we use for any kind of analysis in our project, what do you think, that particular data, is it a population data set or sample data set? Is it a population data set? Of course no. That is a kind of sample data set, and there this particular concept gets applied. So what we do is we used to take various samples from the population data set, and we used to perform this particular sampling. And when we just plot that particular sample data set, we used to get distribution in the form of Gaussian distribution, right? So in general term, if I explain you, if you are going to plot the features of a data set, of course, until and unless if there is no such outliers present in the data set, you will be getting the form of distribution in the Gaussian distributed form, that is normal distribution, right? So this is how you can understand relating this concept to the data set. This is all about central limit theorem. I hope you understood. If you have learned something from this video, then please do like, share and subscribe to this channel. Till then, keep learning and keep exploring. Thank you so much.